Thank you. I'm hoping this will be kind of a nice counterpoint to Hannah's talk just now, which was much more about the practicality of how to use tools for packaging. And this is kind of more of an overview of like where packaging has gone and where it's going next. So packaging is really a traditional pain point for Python. Everybody has always complained about packaging. It's never exactly been great. I hope that in this talk I can give a bit of an idea of why it's not already solved and a bit of optimism that things are gradually getting better. So the message is really summed up in this old British Rail commercial from the 1980s. We're getting there. Starting out with a kind of very abridged history of Python packaging. Python 0.9 was actually released to the world back in 1991, but for the sake of not bunching everything up too much on this timeline, I've started from Python 1.0 in 1994. And the first few years after that were kind of packaging was the Wild West. If you had a piece of code that you wanted to share with the world, you would put that up on your website or share it with a news group or something. People would download that and they would follow your instructions to put this file in this directory or run this script that came with it to install it, or do whatever you'd come up with to install it, really. There was no kind of standardized mechanism for anything. It was just up to the individual packages to do things themselves. So the first step towards changing this was distutils, which landed with Python 2.0 and Python 1.6, which were both released in the year 2000. And this was the birth of the setup.py format that many of you will have seen or used today. And the idea was that you would still find your package. However, if you wanted to have a library to draw a graph or something, you would still just go and look on Python-related websites and news groups and things and find something to download. But then hopefully, once you'd downloaded that thing, you would have a standard system that you could unpack this, and then there would be a setup.py file. You could run setup.py install. And internally, that looks something like this. So this is kind of a absolutely minimal example for installing a package. In this case, it has two sort of importable components, and it's got a name and a version number. And then the next big step was in 2003, the first PyPI website was launched. This is what it looked like back then in its Web 1.0 glory. This is courtesy of the Wayback Machine. So this provided for the first time a standard sort of common way to find packages. There was one big list of them on PyPI, and perhaps even more importantly, a way to claim a name. So, if you'd got a package that you wanted to call Django, for example, then you could, if you were the first person to come up with that name, you could claim that on PyPI, and then from that point, you would be the only person allowed to make Django releases on PyPI. Other people could still put up a package called Django on their own website, but PyPI kind of became the place where names are officially defined. And back in 2003, the Python package index was literally just an index. You couldn't upload your packages to it. You would put your packages still on your own website and then put a URL for that on PyPI. And it wasn't until 2005, the sprints at PyCon US in Washington, DC in 2005 added the ability to host your packages on PyPI. And in 2004, setuptools was released. This is a layer on top of distutils, so it adds to the capabilities of your setup.py file. perhaps the biggest feature from a user perspective was the easy install tool. So you could type easy install foo. It would go and look for the foo package on PyPI, download that, install it, and crucially, for the first time, it would look at the dependencies of foo and try to get those as well. Previously, if your package had dependencies, a user had to go and manually get each of those dependencies and install those. So that was kind of a really big change in how you could package your things, because before that time, dependencies were just such a pain that you wanted to avoid them at all costs. It also had this .egg package format, which allowed you to ship precompiled binary extensions. So if you had a Python package that was built in part from C code, then people could install it without needing a C compiler to build that themselves. Eggs had certain issues of their own. They kind of tried to change a bit the way that Python imports worked. An egg package was tied to a specific Python version, even if it didn't have any C code and things. So they were kind of a mixed bag. And there were lots of other features in setuptools because, again, back at that time, packaging was hard, so people didn't tend to make lots of small packages for separate bits of functionality like we hopefully would now. They tended to do sort of big, lumped together packages that brought you lots of things in one go. And the next step, as you were hearing all about if you were here for Hannah's talk before, is kind of pip and virtualenv. So virtualenv actually came in a year before pip, but I'm kind of bracketing them together here. Easy install never had an easy uninstall. Part of the idea with egg packages was that you could just delete them entirely. But pip brought uninstall for the first time. And between them, pip and virtualenv kind of backtracked on the egg model and kind of went back to a more standard structure of you have all of these importable packages in one big directory. And pip never actually gained the ability to install egg packages. So a lot of the scientific Python world, tools like NumPy and SciPy, clung on to eggs for quite a long time after pip was released because it gave the ability to distribute precompiled binary packages. So you would still see some of these tools recommending easy install this rather than pip install this, because pip installing it would try to build from source, which can take a long time and can require a lot of extra things. So that kind of, from a user perspective, if you just want to bring tools in and use them, that kind of seems to bring us up to date. But from an infrastructure perspective, there's a problem, and we're going to fill in the other half of this timeline. And the problem really is that setup.py runs on the target system where you're installing the packages. So the model is always you download a tarball, you unpack it, and then from that you run the setup.py file to install the module. Why is this a problem? It's super convenient to have executable installation because as a packager you can fiddle around in the installation script and do whatever you want to do. The downside of that, the first downside of that is that if the packager can do whatever they want to do, it's much harder for user tools to control what the package is doing as it gets installed. So for instance, if you want to install that package into a virtual environment and the package maintainer, the package developer, has assumed it will only ever be installed globally, they might have the setup.py write some files into some other folders, assuming that that would be okay, and maybe you don't want it to do that. That might also cause problems for when you want to uninstall the package. Those files might not get cleaned up properly. From a developer's perspective, this thing with setup.py running on the user's system also means that you can't easily switch packaging tools because the setup.py can only use things that you can assume are already installed on the user's system, which basically means distutils and setuptools. Distutils is in the standard library. Setuptools has just become so widespread and is kind of enforced by PIP that you can assume that's there. And even if you could assume that something else was there, it's never really been defined exactly what PIP needs setup.py to do. It's just it needs it to do the things that distutils and setuptools do. So it's implementation-defined behavior. And last, it can be quite slow. So the solutions to these problems are the points that have turned up on the timeline here. So the first bit of the solution landed in 2013 when the wheel package format arrived. So this is flipping the Python punning around again. The egg package format was Pythons are snakes. The wheel package format is a reference to the Monty Python cheese shop sketch, Wheels of Cheese. So a wheel package file has a standard layout. So a tool like PIP can get a wheel and unpack those files onto your system without running any script or any code contained in the wheel. So we're taking away a bit of control from the packages and giving it to the tools on the user side. Wheels also, as with eggs, bring the ability to distribute pre-built binaries, so you can, again, install things that have compiled code without needing a C compiler on the end user's computer. This ability was there for Windows and Mac from 2013 when Wheels were launched. Figuring out how to do that consistently for different Linux distributions took a bit longer, but in 2016 the Mini Linux 1 specification was launched, which defined ways to build, sort of fix and then tag wheels, and allowed them to be uploaded and installed. And this is kind of where I come into the packaging story. So in 2015, I started a packaging tool called Flit on the premise that maybe in this glorious new age of wheels, we can just produce wheels and upload those to PyPI and not worry about the setup.py thing at all. Spoiler alert, it's not that simple. So before Wheels, kind of the distribution and installation flow would look something like this. So the packager starts from their source folder where they're developing the code. They run setup.py sdist to create this tarball. On the user's computer, that gets unzipped, untarred, whether they're doing this manually or whether this is a tool like pip doing it for them. And then setup.py install is run to turn that folder into an installed package. Once Wheels have arrived, we have kind of this extra possibility that, so the setup.py install way still works, but now you can also do setup.py bdist wheel and create a wheel file which you can publish on PyPI, and people can download and install that. And there's no label on this bit because this is just kind of an unpacking step that pip knows how to do without running any command from your wheel. So in a sense, we've kind of cut the link of setup.py between what the developer has and what the user needs to run. But it's still kind of there, and people still want, for various reasons, to install from source. And yeah, so that's the reason that the talk isn't finished yet. So the next part of the solution is PEP 518. So although the number is higher, PEP 518 actually came before PEP 517, and it basically gives you this new config file, pyproject.toml, where you can list packages to install before running your setup.py. So you still need to have a setup.py file. It still needs to do the things that setuptools does, but you have a bit more flexibility with it because it can assume that the things you've listed here are installed before it gets run, assuming that your packaging tools are new enough. And this was kind of very deliberately a precursor for PEP 517, which I'm just about to talk about. It was kind of split out of that discussion as its own separate PEP. So if you've seen the original title of the talk on the schedule, then you'll know that PEP 517 is what I'm officially meant to be talking about. So we finally got there. PEP 517, in terms of what you actually see in a package, it's just adding this one key build backend to that pyproject.toml file that was defined in PEP 518. In terms of what actually went on to get to this point, this was not an easy process. So it took very nearly 2 years from the first message on distutils-sig mentioning the possibility of doing this to the PEP being accepted. I looked through the mailing list archives. There were more than 800 messages that had 517 in the title, in the subject line. There were more messages before that I didn't try to count before the PEP number had been assigned. There were 2 different alternative proposals that did the same thing. So one of them, PEP 517, defined a Python API. PEP 516 defined commands. But in the end, we got there. And what this is, the central feature of this really is that we're defining how to go from a source folder to a wheel. So in terms of that sort of flow diagram that was there before, it's exactly the same, but now going to a wheel, you can do either with the setup.py bdist wheel or with this PEP 517 interface. And the idea is that in the future, that top line, the direct install from source to an installed package, is going away, and all installation will be done by first building a wheel and then installing that. And this is already a work in progress. So if you pip install something that's only available as a source distribution, a tarball, then pip will download that, build a wheel for you, and then install from the wheel. And pip is smart enough to cache the wheels as well. So if you install the same thing repeatedly, it is faster. So what does PEP 517 actually define? So it talks about things in terms of a front end, which is the tool like pip that you use, and the back end, which is a tool that the package distributor has chosen, and setuptools has implemented a PEP 517 backend. Flit, my own packaging tool, also has. And in order to have a PEP 517 backend, there are 5 hook functions that you have to define. 2 of them are mandatory, 3 of them are actually optional. So yeah, there are things like the most central one is build wheel, but there are also things like get requires for build wheel, where the tool can specify, okay, before I can build the wheel, I need to have these things installed. And this was the difference between PEP 516 and PEP 517, as PEP 517 specified this as Python functions. PEP 516 specified more of a command line based API that it will run these things in the package folder. And part of the specification also says that the front end should run these in a subprocess. So it's isolated from the inner workings of the front end tool like PEP. So even if this crashes in some horrible way, pip should still be able to give you a nice error message and say it's that tool's fault, not mine. So some of the things that you can do with tools built around PEP 517. Flit, as I mentioned, is my own tool. It's kind of the simplest useful PEP 517 backend in a sense. So you have declarative metadata that you add into your pyproject.toml file, looking like this. And it builds the package from that with no room to sort of customize how it builds or installs. So it's meant to be very straightforward. It's constrained to simple packages. It can't do anything like C extensions or anything. Poetry, as was mentioned in the Q&A after the last talk, Poetry has a very nice command line interface to manage dependencies. It also has a nice dependency resolver that can handle if different dependencies depend on the same package further down and they want different versions of it. Poetry will do its best to work out like what's a compatible version for everything. It also stores its metadata in pyproject.toml, but whereas with Flit, you're kind of mostly editing that file directly by hand. With Poetry, you can do these things like poetry add and the name of a package that you want to add as a dependency, and it will modify the files for you. And it does some nice locking of specific versions of packages once you've chosen them. Or kind of going to the other end of the spectrum from Flit, if you've got a more complicated package with C extensions, or if you're playing around with integrating a Rust module with Python or something, then you can have a go at using a real build system rather than something that's kind of Python packages and then extended and extended and extended to do more things. So this is Daniel Holth's tool called nscons, which is an extension of the scones build system to give it sort of the ability to generate Python packages. So yeah, this is convenient if you've got things like a Python C extension that you want to build. If none of these options suit, you can also go away and build your own backend. Although please remember, one obvious way to do it, don't make a separate backend for every package that you want to package. But there's relatively little to do if you do want to make your own backend. There's these 4 key functions, and you can also do this by extending another backend. You can have that as a dependency, so you could build on something like Flit or setuptools and make it more capable, so you don't have to write all of the code to do these things yourself. You can also use PEP 517 to make your own front end. So there is a convenience library called PEP 517, which is takes care of running these hooks for you in a sub-process. So that makes it quite easy. You can just call a function and get a wheel or something back. And why might you want to do this? You might want to package Python code into another packaging system like RPM or Windows installers or SPAC, which is for packaging stuff on HPC clusters. You might want to do the actual package building step in a Docker container if you don't trust the code that it's running. You might want to play around with doing reproducible builds, so getting the exact same result from different builds of the same input. Yeah, before I finish, I just want to say, like, I've presented this. This is obviously not work that I have all done because it's an enormous amount of work. Thank you to all of the other people who've worked on packaging, and the people named here are the people who were particularly involved in the PEP 517 discussions. So thank you very much.
We got time for one small question. Yes. I'll go here. He was first. Remember to keep questions being questions.
Thank you for the talk. One thing that struck me
is, in comparison to other language ecosystems, do you think we're in a good place?
That depends which language you're comparing with. I think we're certainly compared to some new tools, new languages like Rust or Julia, I think we're not particularly in a good place because they have the advantage of starting from an empty state. They can build things in a good way from the get-go, whereas we're trying to kind of retrospectively work with all of this history and keep things working while getting to a good state. So yeah, there are certainly other languages that have this better. On the other hand, I think there are relatively new languages, like I think Go, that the packaging is kind of a mess, even though they've got a lot of history that they could have learned from.
Thanks, Thomas. Can you all give a big hand again?